Welcome to Train Signal. You're watching Managing VMware High Availability. So let's talk a little bit about HA. I'm going to hitch up again and say a lot of this is probably review. We'll talk about a few of the advanced topics, but for the most part, you should at least be basically familiar with HA. But if not, let's talk about it, right? So vSphere HA will reboot VMs on surviving hosts should a host fail. So it has to be licensed depending on your license level, and you have to enable it. It's not known by default. It's part of the cluster configuration. But the idea is I have 4 hosts in my cluster, I have VMs running on all of them, host number 3 fails. The VMs that were on host 3 that are no longer running get rebooted on host 1, 2, or 4. That's assuming that we have available capacity, it's enabled, they all have access to the same storage, etc., etc. It uses a master-slave type relationship. I equate this to the old Microsoft, NetBIOS elections and things like that, which some people cringe at. But it's better than the old method that we used to use in vSphere, 3.5 of 4 and all that. It is much simpler. You have a master node, and the rest are slave nodes, and there's some communication. You don't really need to get all too in-depth with it, but just know that the master is selected via election. There is a possibility of multiple masters if we have what's called a network partition where the hosts can't talk to each other, and we kind of have a split, almost a split brain type configuration. But in a normal day-to-day operation, there's one master, the rest of your nodes in the cluster are slaves. And the idea is it primarily protects against vSphere host clusters. And I say primarily because you can enable VM level monitoring using the VMware tools Heartbeat. I know very few people that actually do that because they think they don't trust it, they don't want it rebooting their VMs just because of a heartbeat issue. So most often that's disabled, and people just use it for host failures. Most environments leave HA set to default settings, which isn't always the best idea. They just turn it on, they think, it's magic, it'll just work. But there's some things that you have to think about as you go through. There's some recommended reading. I mentioned this, I believe, in another lesson, but there's a great book by Duncan Epping and Frank Denneman that talks about this in very much detail. Great book, not saying you need to read it for the exam, but I consider any VMware admin who wants to be good at their job should always read the latest version of that book and have it on their iPad or their Kindle because it's great reference. So let's talk a little bit about HA versus DRS. This may seem simple, but it is in the blueprint, so we're going to talk about it. I talk to customers who get these confused. I'll be honest, if you're looking at the VCAP exam, you're probably not going to get that confused, but I still want to review it. DRS is used to balance workload across a cluster. It does not recover VMs in case of failure. All it does is DRS looks at your cluster, looks at all your nodes, goes, that one's a little bit over busy, this one over here is not that busy, I'm going to move some VMs from there to there and balance out the cluster. Pretty simple. HA is used to recover VMs in case of a host failure. Host 3 dies, the VMs that lived on it are restarted on the surviving host. If there's no failures, HA does nothing. It does its election, figures out who's a master, figures out slave nodes, keeps an eye on each other, makes sure that I hear from you and you hear from me and we're all healthy. But as far as actively touching VMs, it doesn't do anything in normal, when everything is good. But they can be used together. So do you have DRS enabled and it's set to the proper mode, so it's at least partially automated, which does placement. If HA says, oh man, host 3 just failed, I got to start to use 8 VMs on these other hosts, where do I put them? DRS will help figure out the best host to start them on using the placement rules. So it is best to couple DRS and HA together. DRS can also get a little smarter than that. If host 3 fails, and you got a big VM that was running on host 3, and neither host 1, 2, or 4 has the resources to run it on their own, DRS will look at that and go, you know what? If I move a VM from host 1 to 2 and another one from 1 to 4, that'll give me enough resources on host 1 to boot that big VM. I'm going to go do that. So then it starts using the automated movement policies of DRS and helps smooth that out and makes it where you can restart those VMs. So again, it's best to use them as a pair. A little bit about HA communication. So HA needs to make sure and detect a host failure. How do I know if a host has failed? For HA to function, all hosts must do it, and they do it either via the network, and a new feature in 5 is via storage. We've done it via the network for a while. That's the way, what I'll call HA Classic used to work. The problem with that is if the network switch goes down, but the hosts are up, they're all talking to the same storage, It's not technically down. It's just network isolated. Well, now we can use storage as a sub-channel. Hosts also confirm if they are isolated. The reason I kind of talk about isolation is it's important. If I've got a cluster, host 3 is running some VMs, and his network goes down, he's going to think he's isolated. And he's going to go, okay, either everybody else just died, or network isolation. Well, I need to figure that out, because then we're going to say what happens when you get a host that's isolated. What do you do with the VMs? Do you leave them on? Do you shut them down? Do you power them off? What do you do? So it's important to make sure that we are actually isolated before we take drastic measures. And that's the nice thing about being able to use storage. Now isolated hosts can talk over storage. We call them heartbeat data stores, but they may not be able to talk over the network. So basically you can leave a piece of information on the disk, and hopefully the other guys will pick it up and go, well, huh, I can't ping host 3, but he's still alive. So his VMs are up and functioning. Let's not shut them down, or let's not try to boot them up on the other host and end up with duplicate VMs running. So it's a way to make it more intelligent. Network communication is fairly simple. Sends out heartbeats over the network, sent every second by default. If a host thinks it is isolated, it will ping an isolation address. By default, the isolation address is your default gateway. So that's what it uses. What if, you don't allow pings to your default gateway? Or what if you go, it's great to ping the default gateway, but what if we could also have him ping a backup address just in case? Well, that's what you can do with the overridden using your DAS isolation address commands. So these are advanced HA options. We'll see them in the lab that you configure under the HA config, and you do das.isolation address, and in brackets you put, I think, 0 through 9. Didn't even see my own notes, but you can put 0 through 9, so you can have up to 10 of them, and you can tell it what to ping. You can say the gateway, you can say the gateway and that router also that's over there, or something else, and it will ping those. That way, if you can't ping the default gateway because it's blocked or filtered, or you just want a backup, you can do that. It's a good reason to make VM kernels redundant. If your main management VM kernel only has one NIC plugged into it and the cable goes bad, or I walk by and trip over it, you don't want it to think it's isolated just because we unplugged that. So it's best to have redundant VM kernels. You should do that anyway, but I'm going to harp on it again here. Storage communication is cool because it's new and it's shiny. But it's a backup channel to network. Provides protection against what we call network partitioning, meaning if I have 8 hosts in my cluster, and 4 of them connect to this top of rack switch, 4 of them connect to that top of rack switch, and then they talk over a distribution switch. What happens if there's a problem on the distribution switch? We've just partitioned that cluster into 2 separate pieces. They're going to start having elections, figure out who's a master on each side, and all that, which is fine because that's the way it's supposed to work. But with the storage channel, they'll know that the other ones are up, they'll know that the network is partitioned, and they'll be aware of that. It uses 2 or more data stores for a backup heartbeat. Has to be at least 2. One doesn't do the job because one may be down or there may be an issue, so we want 2. You have the option. You can say, I want to choose these data stores, or you can say, just go pick some data stores for me. And it'll pick the ones that make the most sense. So if you're a crazy vSphere admin, you got a 8-host cluster, and 6 hosts can see this data store, and 4 hosts can see that data store, but and then there's a 3rd data store that they all see. It'll pick the ones that make the most sense. So it'll pick the one that they all see, and I believe it'll pick the one that 6 see. Why you'll do this, I don't know, but there's an algorithm that it uses to select that. My suggestion is don't split up storage like that. Make sure everybody in the cluster sees the same storage, but it will try to be intelligent about how it chooses it. Also, it's not resource intensive, so don't think, well, I got to dedicate disks, or I got to do this, or I got to do that. Just pick a data store. It's not that big a deal. It's not going to write a ton of information. It's just a heartbeat if it can't talk on the network. Best to select data stores that do not share connectivity. Well, that's great. So that's a great reason to manually select. Maybe I've got some NFS data stores, some iSCSI data stores, and some fiber channel data stores. I'd pick one of each at least. That way, if fiber channel fabric goes down, heaven forbid, it's rare, but it happens, you'll still have backups. That way, a loss of iSCSI switches because something blew up doesn't cause a complete outage. So mix and match if at all possible. If all hosts in a cluster don't see at least 2 common data stores, I suggest you create them. So I just talked about that. Again, First of all, don't do that. But if you did do that, make it so everybody can see them. Isolation response. If a host stops receiving heartbeats and cannot ping the isolation address, it goes into isolation mode. It freaks out. Then it has to decide, what do I do? What do I do? Am I down? Can people get to me? What's going to happen? And you have what's called an isolation response that tells it what to do with the VMs. Leave them up, shut them down, power them off the hard way. You don't want to end up with a split brain scenario where HA starts up the VMs on another host and they're still running on the isolated host, and weird file locking issues start to happen. So you need to figure out what you want to do. So here's the 3 of them. The fun part is the defaults have changed over time. I believe the latest is it's still leave powered on. But leave powered on is the highest risk of split brain, but it's the safest. Most people, and the reason this is the default is people feel like it's better to not have HA shut them down. I'd rather have my servers up and take a slight risk of split brain than have it shut them down. Shutdown is graceful shutdown. Power off is just pull the power out. The idea there is I don't want any chance of 2 copies running. It's the alternate, the converse of leave powered on. I'm probably going to tell you to leave it on. Duncan and Frank have discussed this stuff in depth in the book that I mentioned, but for most of the time we usually set it to leave powered on, just again to reduce the risk of an outage. Which to use depends on your environment, like I said, and what risk you want to assume. So there's no right or wrong answer here, but more people lean toward the leave powered on. So let's talk about how you calculate host failure requirements, because the last thing I want to see you do is spin up a cluster with 8 nodes, fill all those 8 nodes up to 90%, think you're getting great ROI, and then you lose a host one day and wonder why HA doesn't restart all your VMs. So HA allows you to define how many host failures the cluster can absorb, and that dictates how much usable capacity is available. And it's often not set as a number of hosts, but I prefer it to be set as a percentage of the cluster. Most common to see 1 host worth of resources reserved. So it's usually, we call N+1 redundancy. If I've got 8 nodes in a cluster, I'll spin up enough VMs to fill 7, and I'll leave enough resources for 1 to take a failure. Some people will do N+2 so they can fail 2. They figure, okay, I'm in the middle of a maintenance window, I got my host in maintenance mode, and then another host fails. What do I do? So they'll go ahead and bite the bullet and pay the extra and do N+2. That's up to you. It's up again to your risk and all that, and figuring out what you want. But again, most people do N+1. And you need to do some work to be precise. Not everything in life, is simple. And this is one of those things. HA will do some basic calculations for you, but it just depends on your environment whether they're correct or not. So before we jump into how it does it, let's talk about enabling it. We call this admission control. This is a feature that people turn off, forget they've turned it off, and wonder why HA didn't restart their VMs when a host failed. So admission control tells vCenter to protect the reserved HA resources. Have you ever been working in an environment, you go to power up VM, says, sorry, not enough available resources due to a constraint due to admission control. And you go, oh man, well, I just need to do this for a few minutes. So you go edit settings on the cluster, go to HA, turn off admission control. Did you ever go turn it back on, or did you just keep spinning up VMs and now you don't have any recovery space? That's what I see a lot of. So it won't let you power on a VM that would not be protected in a failure. Please enable admission control, unless it's a lab and you don't care if things go down. So seriously consider enabling that. There are 3 options for setting reserved capacity. You can do number of hosts. Best of all hosts are the exact same, and you want reserved capacity on multiple hosts. Percentage of cluster, commonly used. You basically specify a percentage. So if it's a 10 node cluster, you may do 10%. You may do 20%, whatever you want, but it's a percentage, not a number of hosts. Why would you choose one or the other? They can kind of be the same if all your hosts are the same. If all your hosts are not the same, then a tenth of a 10 node cluster may not be the same as 1 node in a 10 node cluster. So just keep that in mind. The third one is specify failover host. I don't like this one. Nobody likes this one. But you basically say, hey, host 4, you're the failover host. Congratulations. And nothing else runs on host 4 until there's a failure. And then everything that was on the failed host starts up on 4, else it sits there idle. The downside to that is no DRS. You don't get to take advantage of that in the good days. You only get to use it during the bad days. Now let's talk about slot sizes, the ugly side of high availability, and probably the thing they're going to hit you on in the exam, because enabling HA is easy. Setting your resources, that's not too bad. Slot sizes, that's what gets you. So admission control uses the concept of slot sizes. It defines a certain size VM based on CPU and memory and calculates the slots available in the cluster. So it says, we'll calculate this VM to be this much megahertz of CPU, this much memory. If I slice and dice up the cluster, I got 87 slots. And if you say I want to protect 10%, that's 9 slots out of the 87 because I round up. And it's 9 slots. That's all well and good, assuming you don't have varying sizes of virtual machines. The CPU size is the largest CPU reservation on a VM. Reservation. If you don't reserve CPU, it's set at 32 megahertz, which is basically meaningless. And that makes sense. It's hard to dictate CPU size. But you will see some things like virtual app or virtual appliances, like the Nexus 1000V sets a CPU reservation just to make sure it gets some processing time, and that will dictate slot size for you. So keep that in mind. Memory size is the largest memory reservation plus overhead. If there's no reservation, then it's 256 meg plus overhead. Remember, overhead is dictated by memory and number of virtual CPUs. Over on the right, and I'll show you this in the lab, is where you can pull this information up. Number powered on VMs, number of hosts, number of available slots, failover slots, used slots, total slots, what my slot size for 32 megahertz, 1 vCPU, and 3144 megs of RAM, so a little over 3 gigs of RAM. And that's out of my lab. So you can kind of see that, and we'll show that to you in the lab. So you can create custom slot sizes. And the idea is a large VM can mess up the automatic slot size calculation. So what happens if you have one big VM with an 8 gig memory reservation, because the SQL DBA just had to have a SQL or memory reservation on its database server. Well, all of a sudden that messes your slot size up, because every slot size got 8 gig. And that's not practical. So then you try to figure out what you need to do. And the way you do this is you create your own slot sizes. You define these in the advanced options in HA cluster settings. So it's DAS for all of them. VM CPU min sets the default CPU sizing. VM memory minimum sets the default memory sizing. And then you can set the maximum CPU slot and the maximum memory slot. So you can set the default and the maximum. So if you get an 8 gig and you think that's too big, I want to make sure I don't want to set everything to be 1 gig, because that 8 gig VM is going to be 8 of those slots, and that's not really right. Maybe I'll set it to be a 4 gig maximum slot size. You can do that, and that's where you do it. So you go into HA cluster settings and add these options. VM settings can specify options on a per VM basis. So within HA, we can dictate a few things. VM restart policy, host isolation response. So you can say, hey, if this host fails, and you got to restart these VMs. This one's high priority, that's medium priority, that's low priority, and don't bother restarting that guy. We don't like that guy, so don't restart him. You can also specify host isolation response on a per VM basis. So you can say, if something's super ultra mega critical, maybe instead of power off, you would say leave that one powered on. Where my default is powered off, we're going to leave that guy on, or vice versa. So you can pick and choose that on a case-by-case basis. VM restart policy, as I said, lets you set what you want to start first, set to high. You can also specify the VM will not be restarted. It's specified as disabled. So if you have something that's really important, or you want to make sure it comes up first, just set it to high. Host isolation response lets you specify different response in default. So again, you may want certain VMs left on or powered off. HA alerts. vCenter supports several alerts for HA. Obviously, it supports alerts for a ton of things. Make sure you're aware of an HA event. You configure them within vCenter like all alerts. Probably want to be notified should VMs be restarted. Here's an idea of some of the alerts. So you can go into those alerts, change them, specify how you want to be notified and what you want to happen. They like talking about alerts in the blueprints in each of the section. I would spend a little bit of time in vCenter revisiting those. Again, alerts are VCP kind of level stuff. We can look at them. But I would spend a little bit of time making sure you know how to manage, enable, disable, and configure those. So let's do some lab work, shall we? In the lab, we're going to enable HA, configure HA settings, host monitoring and mission control, VM options, data store heartbeats, and look at the advanced options, mainly custom slot sizes. I'll just show you where to add custom slot sizes. We'll try one out and see what happens. So with that, let's go ahead and jump to the lab. Alright, back to the lab. So first thing we want to do is we want to enable HA in the cluster. So let's take a look. We'll right click the cluster, edit settings, and it's basically as simple as turn on vSphere HA. Hit OK and you're done. Go take the exam, right? Well, not so fast. So let's go ahead and kick off the job. Let's see. Tasks. Obviously, it's going to go through configure HA on each of the hosts. If you've used previous versions of vSphere 35441, you know this can take a long time. One of the great things about the rewrite of HA for vSphere 5051 is it's much quicker. So we'll let that do its thing while we go and play around with the options. So edit settings. Now we have a tree of things. So let's look at each thing. Host monitoring. ESX hosts in the cluster exchange network heartbeats. So don't disable this unless you're doing maintenance. If you're doing network maintenance, you may cause isolation issues if you take a switch down and they can't ping. So you could turn this off for temporary times. But for normal times, leave this on. And here's the scary admission control. So this is the one that says, hey, I've got some protected resources. You're not allowed to use them because one day a host is going to fail and you're going to thank me for it. But, if for some reason you need to temporarily enable all resources for use, you can disable this, and it's going to disable the stuff at the bottom. We're going to enable it. Down at the bottom, we've got a few things. So, admission control policy. This is where the three options where you can specify what you want to do for failover. So you can say, I want this, I want 1 or 2 hosts, up to however many you have. I do not have 10, so it'll let you pick whatever. But I'll say 1. You can say 1 host. Again, that's 1 host's worth of resources, not a specific host. We'll get to that in a second, but 1 host's worth of resources. Or you can say a percentage. I want to do, 10% of CPU and 30% of memory. Whatever. They don't have to be the same. In a lot of cases, they're not. Since CPU is not as constrained, you might not want to limit things as much. So you can set a percentage. This is the one that I like and most people like. Again, 1 host is only 1 host worth if all your hosts are the same, else it gets a little dicey. If your hosts are a mix, you haven't upgraded the RAM on all of them, or CPUs are different, you may want to go on a percentage basis. And then you can specify a host, so you say that, you click edit, you say I want this guy, you say OK, and it'll use that host and only that host for failover capacity. Say OK, and off it'll go. So, you got some options there. Just depends on what you want to do. Go back in and change that. Go through the other settings. Host failures 1. Advanced options, these are where we had things like slot capacity. So I went ahead and punched this one in to save us a minute. So this is the slot CPU maximum. And I've got it set to 1,000, so it'll base slots on that. Remember, you have to type these in. You come in here, it's nothing but blank. Then, moving on, we got virtual machine options. So this is where you can go on a case-by-case basis and specify what you want to do for your VM. So at the top, your default restart policy. So by default, everything is started at medium, and then you can dictate high, low, or disabled above that. Host isolation response. By default, the standard is leave powered on, but you can change your default to something else. And then you can go on a VM by VM basis and say, no. This guy's low priority, and in a case of an isolation response, just leave him powered on, or power him off, whatever. So you can go one by one and pick and choose what you want to do. Most people don't bother changing host isolation response. They want everything the same, but they do change restart policy for your more important systems. They'll set those to high. VM monitoring. VM monitoring restarts individual VMs if their VMware tools heartbeats are not received within a set time. Most people set this to disabled. Or if they set them at enabled, they lower the monitoring sensitivity. So it's up to you, and you'll see it here. vSphere will restart the VM if the heartbeat between the host and the VM has not been received within 30 seconds. And it will restart the VM after each of the first 3 failures every hour, all the way down to low, which says it's a 2-minute timeout and 3 failures every 7 days. So this used to be, this has gotten better. In the early days of this, it was a little bit too twitchy, and it would restart VMs on you. So you can go in here and custom and set your own. But again, most people leave this disabled. But be aware of the settings, and also be aware that you can, again, change it on a VM by VM basis and decide what you want to do. Application monitoring is really cool and not really used yet. The idea there is you'll be able to plug stuff into applications like Exchange and say, that's great that the Exchange VM is giving me a heartbeat, but the Exchange service is dead. So how about letting me know when that happens so I can restart that VM and kick the application? So VMware's got the APIs for it. We're just not seeing it used very much yet, so nothing great there. And then data store heartbeats. So we talked about this. This is your sub channel for your heartbeat information. So you've got some options. Select only from my preferred data store, so only from these. You can say select any of those, which means it'll select 2 of those, just like it would select 2 of those from your preferred. Or select any of these, taking into account my preferences. So you can go through and pick and choose as you want to. Usually I just say any, because like I said, it's intelligent of how it's going to figure it out. And after I berated you for, having data stores that not all hosts can see, you see I've got that now because Megatron here doesn't have access to these right now. But I normally say any, or you could just say only from my preferred. It's really up to you, but I say it. But in the exam, if they say, hey, you want to use data store 5 and 8 for your heartbeat, just come in here and pick and choose what you want to do. And if you're wondering what the difference here is, it's a little confusing. So the reason I say, hey, if they tell you 6 and 8, only the 2 that you select, or only, it's going to select 2 from only the ones that you specify. If you do this one, it's going to select the best ones, but it's going to try to use yours first. So that's really badly worded. But this is kind of like, try to use mine, and this is going to be, hey, use 2 out of these. So again, I would say select all 3. So the only tricky part within HA is figuring out what your failover capacity needs to be. And again, it's kind of one of those things you have to calculate out and figure out what you want to have for redundancy, N+1, N+2, and take a look at your VMs and probably do a percentage basis. So if we hit OK, we'll go ahead and we'll take a look. I bet it was moving everything off of Megatron because I set him as the failover host a minute ago. If we want to take a look here, let's see. Yeah, it was clearing everybody off so he could be a nice failover host. One thing you can see in the summary tab, let me get rid of this, is advanced runtime info and some HA info. Now, advanced runtime is where you see your slot sizing. That's good, but it's only available if you specify number of hosts. If you do percentage, this goes away because slot sizes is confusing. But slot sizes really only matter if you specify X number of hosts worth of failover, because it's choosing that and then it's splitting hosts up based on how many slots can fit into a host. Whereas a percentage basis, it's just X amount of CPU and X amount of memory, and that's it. So it is confusing. But if you flip this off of, one host to an X percentage, this option goes away. We'll come back to this in a second. This shows you real quick that admission control is enabled. Current failover capacity is 0 hosts. Configured failover capacity is 1 host. Monitoring is enabled. VM monitoring is disabled. Application monitoring is disabled. So I don't really have enough failover capacity. If you notice, insufficient resources to satisfy vSphere HA failover. So I'm not following my own recommendations in my lab, but I'll show you some of the reasons why that is. So I've set it for 1, but I really don't even have 1, and that's why it's throwing the warning. So I bet you if I come over here and try to boot something, let's boot something like that. Yep, insufficient resources to satisfy configured failover level for HA. That means admission control slapped my hand and said no. So let's take a look. If we look at our slot sizing, we can see that 32 megahertz, 1 virtual CPU. So that looks to me like I have no CPU reservations because that's the default as the minimum. But I do have 3144 megs of memory. So it looks like to me I have about a 3 gig memory reservation and maybe some overhead. And I just happen to know which VM that is. That is vShield Manager. So if we edit this guy, go to Resources, go to Memory, go to Reservation, turn that off, give that a second to click, we come back in and see that that's now updated. So we're still a little bit too slot heavy, so let's look at our VMs again. Scroll over, and I have turned on reservations somewhere. Maybe, maybe not. Right click, reservation in megs, size. So here's one. I got a couple of them with 2 gigs. 2 gigs, 2 gigs, 2 gigs. These guys. So let's turn him off. Say OK. Don't know if it'll let me turn him off without shutting him down, because we've got hot add and all that enabled. That did good. And I'll shut it off for him for now. Okay, so let that settle out. And now, hey, my warning went away. I now have 1 host worth of capacity because I had some memory reservations. Honestly, I didn't need anymore. They're from other lab stuff and things that I've done. And we see now that my slot size is now 440. Total slots in clusters now 162. We're using 36. I got 60 available. I got 66 failover. So I'm good to go. I can now start to boot that VM. So if I wanted to go here and boot this DR vCenter, it will let me do that. So that's one gotcha about watching for memory reservations. And this is one reason that I like to show this demo, because I had capacity in the cluster. Those reservations were there just as a safeguard and for demo purposes and some other things we've done in the labs. And it kept me from using resources adequately when I could just go in here, look at that, and go, oh, there's the problem, slot size, and go adjust that. So that'll help. That'll give you an idea of what you need to look for. The rest of this, cluster status is just going to tell us who the master is in our HA configuration. So who's the master? Number of hosts connected to the master. I got 3 hosts, so the other 2 are connected to him. VMs that are protected. VMs that are unprotected for some reason. For some reason they don't have HA protection. Maybe there's a problem on a host. Maybe HA couldn't be started, something like that. Or, if you've got VM direct path, you're passing through a PCI device, you can't use HA for those guys because you can't fail that VM over. So it'll show you that. And then it'll show which of the heartbeat data stores it's using. It'll show you which host is using which one. So this is kind of funny, like Optimus is using that one, these 2 guys are using this one, and they're all using this one. That's because due to some of the lessons in the course here, I've had to do some weird things to some of these hosts. Normally, all 3 hosts can see all data stores, so we'd have no problems. Let's see, what else? Let me pick a host. Summary. Scroll down, and you will see fault tolerance. HA status, so it says running, and it'll say master. You can click this. VC HA host has been elected as the master. And if we go to one of these guys, summary again, it'll say connected as a slave, so you can see the status, make sure everything's good. If for some reason HA is not functioning on a host, you can right click it and do reconfigure for HA, and it'll go through the configuration process. There are times, don't see it nearly as much on vSphere 5 and 5.1 where I have to do this, but 4, oh man, you'd enable HA on a big cluster in 4, it would take 20 minutes and then it would error on one of them. We had to go back in and reconfigure that one host. Don't see that as much anymore. And then for virtual machines, click on summary, and you'll see that it tells you its HA protection status, and it'll tell you what it's going to do, how it's going to do it, and all that. Just a quick way to see everything. So again, for the exam, slot sizes for sure. I believe that those are documented in I believe it's the availability guide is where those are documented in the documentation set. So know where to look for in case you need to copy and paste those guys in there. Know how to set your admission control and the type. Figure it out. Know how to set your VM restart or isolation response and how to do it on a per VM basis. Know how to set your restart priority on a VM basis. And the rest I think is fairly simple. I wouldn't be surprised to see some heartbeat data store. That's real simple. It just, decide if you have to specifically pick a couple or from these. So know where you do that. But I think that's it for the lab. Back to the slides. And that's it for the lesson. So a lot of this may have been review for you, but it's good to know it, especially with the new stuff like data store heartbeats and some of that. Some people don't get into managing slot sizes, so it's important to understand that. But all in all, it's pretty standard stuff here for this part of the exam. I like questions like this on these exams because hopefully they're things that are very straightforward, very easy to do. They're not a lot of CLI commands with long options. It is what it is, and you just go configure it. So that's it for this lesson. I look forward to seeing you on the next one.